Ground force can shoot down drones very easily than before. I mean the serious ones, the ones that can carry explosives, spy on military bases, or shut down entire airports. And honestly, it's gotten to the point where countries are scrambling to figure out how to stop them. Meanwhile, shooting one down with a traditional missile could cost millions. But that was a long time ago, and today the military and defense companies have been working on all kinds of crazy solutions. Some of them are high-tech and futuristic, others are surprisingly simple. So let me walk you through every major anti-drone weapon system that exists today, what they're good at, and where they fall short. RF jammers, the signal killers. Alright, so the most common way to stop a drone is to mess with its brain. Most consumer drones rely on radio frequencies to communicate with their operator. Cut that connection and the drone either lands, hovers in place, or tries to fly back home. RF jammers work by flooding the airspace with noise on the same frequencies the drone uses. Think of it like someone screaming over a conversation so loud that nobody can hear each other anymore. Drone Defender, Battelle. The Drone Defender is probably one of the most well-known examples. It looks like something out of a sci-fi movie, basically a rifle-shaped device that weighs about 15 pounds. Point it at a drone, pull the trigger, and it jams frequencies like 433 MHz, 2.4 GHz, and 5.8 GHz, which are super common for consumer drones. It even has a separate trigger for GPS jamming, which stops the drone from using waypoints or returning home. The range on this thing is about 1 mile, which is pretty solid. Its advantages is that it's non-destructive takedown, it works on most consumer drones, and it can jam both control and GPS signals separately. Its disadvantages is that it's heavy at 15 pounds, useless against autonomous drones that don't rely on RF signals, can interfere with other electronics nearby. Drone Gun Tactical, Drone Shield. Then there's the Drone Gun Tactical, which is way more portable. It only weighs about 4 pounds and can cover multiple frequency bands at once. So not only does it cut off the remote control signal, but it also stops the video feed. The drone basically goes blind and deaf at the same time. This is the Mark III variant and it's battery powered, making it super mobile for field operations. Advantages: lightweight and portable. Covers multiple bands simultaneously, stops both control and video feed. Disadvantages: shorter range than the Drone Defender, still ineffective against autonomous drones. Battery life can be a limiting factor. Drone Buster, Flex Force. And if you want something even more advanced, there's the Drone Buster. This thing can work beyond line of sight, which is pretty impressive. It includes an RF power meter and analyzer, so it can detect control signals, video feeds, and telemetry data even in low visibility. It's like having X-ray vision for radio waves. The system can counter drones in cluttered environments where visual detection is difficult. Advantages: beyond line of sight capability, built-in detection and analysis, works in low visibility conditions. Disadvantages: more complex to operate, higher cost than simpler jammers, still can't stop fully autonomous drones. Titan CUAS Blue Halo. The Titan system is a portable RF jamming and detection system that's been supplied to Ukraine by the US. It's designed to be highly mobile and can be deployed quickly in the field. The system combines detection with mitigation, giving operators a complete picture of the drone threat before engaging. Advantages: combines detection and jamming in one system. Portable and quick to deploy. Proven in combat conditions. Disadvantages: requires training to operate effectively. Limited against swarms. Autonomous drones remain a challenge. The big picture on RF jammers: they're non-destructive and relatively affordable. But here's the problem. Autonomous drones are becoming a thing. I'm talking about drones that use SLAM technology, simultaneous localization and mapping. These drones create 3D maps of their environment using onboard sensors like LiDAR. They don't need GPS or a remote control signal, they just fly themselves. So if a drone is fully autonomous, an RF jammer is basically useless. It's like trying to jam a robot that doesn't need Wi-Fi. GPS spoofers, the navigation hijackers. GPS spoofing is more sophisticated than jamming. Instead of just blocking the signal, a spoofer sends out a fake GPS signal that's stronger than the real one. The drone thinks it's somewhere it's not, and you can basically steer it wherever you want. Regulus GPS spoofer. Regulus makes specialized GPS spoofing systems designed to take control of a drone's navigation. You can redirect it to a safe landing zone or even capture it intact. Ukraine has deployed systems like Pokriva that use GPS spoofing to mislead Russian Shahed drones. Advantages: allows for controlled capture of the drone, can redirect threats away from sensitive areas, preserves the drone for forensic analysis. Disadvantages: high risk of disrupting other GPS-dependent systems, typically restricted to military battlefield use, doesn't work on drones using alternative navigation like visual odometry. Net guns and capture systems, the physical catchers. Okay, so if jamming doesn't work, the next option is to physically capture the drone. And yeah, I mean literally throwing a net at it. Skywall 100. The Skywall is one of the more popular net gun systems. It uses compressed air to launch a net at the drone, which tangles up the rotors and brings it down. The handheld Skywall 100 weighs about 22 pounds, which is pretty heavy, but it has a smart scope that automatically compensates for the drone's speed and range. There's also the Skywall 300, which is a permanent installation version for fixed site protection. Advantages: captures the drone intact for forensic analysis, non-explosive and relatively safe. Smart targeting system assists with aim. Disadvantages: very limited range, only a couple hundred feet, heavy and cumbersome. Drone can easily evade by flying higher. Single shot system requires reload. Drone Hunter, Fortum Technologies. Then there's the Drone Hunter, which is kind of a genius solution. It's a drone that hunts other drones. It flies up to the target, uses a camera to lock on, and then launches a net. The Drone Hunter's motors automatically detach to propel the net forward. After capturing the target, the Drone Hunter deploys a parachute and lands safely. Advantages: extended range compared to ground-based net guns. Can pursue and intercept agile targets. Reusable system. Disadvantages: the target drone crashes uncontrolled to the ground, difficult to use in urban environments, can struggle against very fast or evasive drones, requires operator skill. Cyber takeover systems, hacking the drone. This is one of the coolest methods. Instead of destroying the drone, you hack into it and take control. Enforce-Air. Defend Solutions has a system called Enforce-Air that does exactly this. It exploits vulnerabilities in the drone's communication protocols and lets you hijack the controls. You can land the drone safely, identify the operator's location, and preserve the evidence. Advantages: precise and low-risk solution. Captures drone intact for forensics. Can locate the pilot. Works on both piloted and autonomous drones. Disadvantages: relies on a library of known drone protocols. Ineffective against custom-built or military-grade drones. Requires sophisticated technical knowledge to operate. High-power microwave HPM systems, the EMP blast. Alright, now we're getting into the serious stuff. High-power microwave weapons generate an electromagnetic pulse that fries the drone's electronics. It's like hitting it with a mini EMP. Phaser, Raytheon/RTX. Raytheon's phaser system can take out entire swarms of drones at once. It creates a beam of microwave energy that disrupts or destroys the drone's internal circuits. The system is mounted on a standard military vehicle and can engage multiple targets in rapid succession. Advantages: speed of light engagement, can defeat entire swarms simultaneously, relatively low cost per shot compared to missiles. Disadvantages: very high initial system cost, significant risk of collateral damage to nearby electronics. Drone falls uncontrolled, requires substantial power supply. Leonidas, Epirus. Epirus's Leonidas system is another HPM weapon designed specifically for counter-drone operations. It uses solid-state technology to generate powerful microwave pulses that can disable drones at range. Advantages: solid-state design is more reliable than older HPM systems, scalable power output, fast engagement time. Disadvantages: expensive to acquire and maintain, collateral electronic damage risk. Weather and atmospheric conditions can affect performance. HPEM Systems. Diehl Defense in Germany produces high-power electromagnetic systems that work on similar principles. These are being developed for European military applications. Advantages: European alternative to US systems, designed for NATO interoperability. Disadvantages: still in development and testing phases, and there is limited deployment data available. Sometimes you just need to shoot the thing down. Traditional firearms can work, but they're not very effective against small, fast-moving targets. That's where AI-enhanced targeting systems come in. The Smash 2000L is an optic that attaches to a standard M4 rifle and uses AI to track and hit drones. It's like having aimbot in real life. The system acquires the target automatically, and the soldier just needs to pull the trigger. The weapon system does the rest, compensating for movement, range, and wind. Advantages: uses standard ammunition, 5.56 millimeters, relatively low cost per engagement, can be mounted on existing weapons, increases hit probability dramatically. Disadvantages: limited range, requires line of sight, falling debris can be dangerous, not effective against swarms. Vampire, L3 Harris. The L-3 Harris Vampire system fires laser-guided 70mm rockets from a palletized launcher that can be mounted on a standard pickup truck. It's been deployed in Ukraine and has proven highly effective against drones. The system provides precision engagement at extended ranges. Advantages: long range, high probability of kill, mobile platform, proven combat effectiveness. Disadvantages: expensive per shot, around $100,000 per rocket. Overkill for cheap drones. Limited magazine capacity, requires trained operators. Coyote Interceptor, Raytheon/RTX. Raytheon's Coyote is a small, cost-effective missile specifically designed to engage and destroy UAS threats. It's part of the QRFS Q-band radio frequency system radar and interceptor package. The Coyote can be launched from a tube and uses sensors to home in on the target. Advantages: purpose-built for drone interception. More cost-effective than traditional missiles. Can engage beyond visual range. Works with integrated radar system. Disadvantages: still expensive compared to the drones it targets. Single-use munition. Requires supporting radar infrastructure. Standard firearms with training. The U.S. military is also training soldiers to engage drones with standard weapons at the Joint Counter Small Unmanned Aircraft Systems University, JCU, at Fort Sill. They practice shooting at balloons dangling below drones, which simulates the difficulty of hitting a small moving target in high winds. Advantages: uses existing weapons and ammunition. No additional equipment cost. Every soldier can potentially engage. Disadvantages: very low hit probability without specialized optics. Limited range. Requires significant ammunition expenditure, not practical against swarms. High-energy lasers. Okay, so this is probably the most futuristic solution. Laser weapons use a focused beam of light to heat the drone's surface until it melts, catches fire, or its electronics fail. Directed energy systems. Lockheed Martin has been developing laser weapon systems for years. They currently have a 100 kilowatt model, which is considered the minimum for shooting down mortars and small drones. They're now testing a 300 kilowatt laser that's powerful enough to take down not just drones, but also missiles and aircraft. Advantages: extremely low cost per shot, just electricity, a few dollars. Speed of light engagement, nearly unlimited magazine with power supply, highly precise. Disadvantages: extremely high initial cost, tens of millions. Performance degraded by clouds, fog, rain, smoke. Eye safety concerns, requires substantial power generation. Iron Beam, Rafael Advanced Defense Systems, Israel. Israel's Iron Beam system is designed to work alongside the Iron Dome, providing a cost-effective way to intercept drones, rockets, and mortars. It uses a high-energy laser to destroy threats at the speed of light. Advantages: integrates with existing air defense network, very low cost per interception, fast engagement, effective against multiple threat types. Disadvantages: weather-dependent, high acquisition cost, still in final testing phases. Power requirements are substantial. Elbit Systems. Elbit Systems also produces directed energy weapons for counter-drone applications. These are being integrated into Israel's multi-layered air defense strategy. Advantages: proven Israeli defense technology, designed for high-threat environments. Disadvantages: limited public information on specifications. Export restrictions may apply. Detection and tracking systems. Before you can stop a drone, you need to detect it. These systems are the eyes and ears of any counter-drone operation. IRIS, Robin Radar Systems. Robin Radar's IRIS system uses micro-Doppler radar to detect drones and distinguish them from birds. The radar can detect the unique frequency shift created by rotating propeller blades, which dramatically reduces false alarms. QRFS, Raytheon/RTX. The Q-band radio frequency system is a sophisticated radar designed specifically for detecting small drones. It works in conjunction with the Coyote interceptor system and has been deployed in various military applications. Advantages: purpose-built for small UAS detection, integrates with kinetic effectors, mobile platform, proven in combat. Disadvantages: high cost, requires trained operators, large footprint, RF analyzers, Dedrone, Rode, and Schwartz, Aronia. These passive systems monitor the electromagnetic spectrum for drone communication frequencies. Companies like Dedrone, Rode, and Schwartz, and Aronia produce RF detection systems that can identify drone types and even locate operators. Advantages: passive operation, no license required, can locate the pilot, relatively low cost, can identify specific drone models. Disadvantages: can't detect autonomous drones. Short range, ineffective in RF crowded environments, requires database of known frequencies. Acoustic sensors. Squarehead Technologies makes acoustic sensor arrays that listen for the unique sound signature of drone motors and propellers. Multiple arrays can triangulate a drone's location. Advantages: detects autonomous drones, passive operation, mobile, good and cluttered environments where line of sight is blocked. Disadvantages: very short range, under 500 meters. Useless in noisy environments, can't provide precise tracking data. Integrated multi-layered systems. The most effective approach combines multiple technologies into a single coordinated system. Atlas EW system. Developed by Kyiv-based firm Kvertis, Atlas is a massive networked system of 8,500 detection and jamming units intended to create a 1,500-kilometer wall of electronic defense along Ukraine's front lines. The system is centrally controlled and automated, allowing for selective jamming of enemy drones, while friendly drones continue to operate. Advantages: massive scale and coverage, centralized control, can distinguish friend from foe, automated response. Disadvantages: requires $130 million in funding. Complex infrastructure, vulnerable to physical attack on nodes, requires extensive maintenance. Enclave system, another Ukrainian EW system designed for frontline drone defense. It's part of Ukraine's layered approach to countering the massive Russian drone attacks. Advantages: combat proven, designed for high threat environment, mobile deployment. Disadvantages: limited public specifications, requires supporting infrastructure. Trident laser system. Ukraine is developing its own directed energy weapon called Trident. According to reports, the system can destroy drones at ranges up to 3 kilometers and blind their sensors at up to 10 kilometers, though further details remain classified. Advantages: domestically produced, designed for Ukraine's specific threat environment. Low cost per engagement. Disadvantages: still in testing. Limited information available. Unknown reliability and effectiveness. FPV interceptor drones, the swarm fighters. Perhaps the most innovative solution to come out of Ukraine is the use of cheap FPV first-person view drones as kinetic interceptors. Sting, Wild Hornets, Ukraine. Ukrainian company Wild Hornets produces the Sting interceptor drone. These are fast, agile FPV drones piloted by skilled operators who physically ram them into Russian Shahed attack drones. By October 2025, these interceptors were responsible for the majority of Shahed shootdowns. Advantages: very low cost per engagement, highly effective against Shaheds, can be mass-produced quickly, uses existing pilot skills. Disadvantages: requires skilled operators for each drone, needs extensive supporting infrastructure, radar, command posts. Pilot fatigue is a factor, not effective against fast or evasive targets. Octopus 100. A joint UK-Ukrainian effort is underway to mass-produce the Octopus 100 interceptor. President Zelensky set an ambitious goal of producing 500 to 800 interceptor drones per day by November 2025. Advantages: addresses the scale of the threat, international cooperation, rapid production capability. Disadvantages: massive infrastructure requirements, needs hundreds of trained pilots, sustainability questions remain. The unconventional birds of prey. This one sounds insane, but it's real. Some security companies have trained eagles to take down drones. Trained eagles, various security firms. The bird literally grabs the drone out of the sky with its talons and brings it down. This has been tested in Europe and the Middle East. Advantages: incredibly precise tracking, natural and non-electronic solution, effective in specific scenarios. Disadvantages: training takes years, requires skilled falconer. Here's the thing that became super clear after looking at all these systems. There's no perfect solution. Every weapon has trade-offs. RF jammers don't work on autonomous drones. Net guns have terrible range. Lasers are expensive and affected by weather. Projectiles cost too much per shot. That's why the military uses a layered approach. You combine multiple systems to create overlapping fields of coverage. Maybe you use radar like CurFS and RF analyzers from D-Drone for detection, Drone Gun Tactical for soft kills, and Vampire or Coyote interceptors for hard kills. You create multiple dilemmas for the enemy, which makes it harder for them to adapt. The war in Ukraine has really driven this home. Both sides are using drones at every level, from tiny FPV kamikaze drones to large reconnaissance platforms. Ukraine has deployed everything from the Titan CUAS system to domestically produced interceptor drones. They're using the Atlas EW system to create electronic barriers and the Pokrova GPS spoofing system to mislead Shaheds. Russia, meanwhile, is launching hundreds of Iranian-designed Shahed 136 drones per month. often mixed with cheap decoys to saturate Ukrainian air defenses. This creates a severe cost imbalance where a multi-million-dollar missile might be used to destroy a drone worth only $30,000 to $60,000. The U.S. military has recognized this challenge and launched the Joint Counter Small Unmanned Aircraft Systems University, JCU, at Fort Sill, Oklahoma. They're training about 1,000 troops per year on systems like the Drone Defender, Drone Gun Tactical, Drone Buster, Titan CUS, Vampire, and Smash 2000L. The goal is to standardize training across all branches and create interoperability, and the technology is evolving so fast. Drones are getting smarter, cheaper, and more autonomous. Russia has adapted its drones with radio detectors for evasive maneuvers and modified flight altitudes to bypass specific defenses. The counter-drone industry is in a constant arms race trying to stay one step ahead. So yeah, if you're asking what the best anti-drone weapon is, the answer is all of them. You need the whole toolbox, because the threat is too diverse, too adaptable, and too cheap to rely on just one solution. The market reflects this reality. Multiple firms project the CUS market will grow at 26 to 29% annually. And honestly, this is just the beginning. As drones get more advanced, the weapons to stop them will have to get even crazier. We're living in the future, and it's both fascinating and a little terrifying.